Now that you've finished learning a little bit about arithmetic sequences, we're going to move on to the next one called geometric sequences. Now, I bet you're clever enough that you can already kind of figure out what's going on here. In an arithmetic sequence, you had a list of numbers. So I'll start with a list of numbers. And in an arithmetic sequence, it was adding or subtracting to get from one term to the next. So in a geometric sequence, you are going to be multiplying. So these numbers are going to be separated by what's called a common ratio. So separated by a common ratio. And basically all that means is it is multiplying or dividing to get from one term to the next term. Generally, we're going to be looking at what is it multiplying by to get from the next. Now, you might be able to figure out that, hey, it's dividing by 2, but another way of saying that is it's multiplying by 1/2. So we're going to stick with whatever it's multiplying by. That's called the common ratio. So first example says determine the common ratio for the following geometric sequences. So to get from -2 to -10, what is it multiplying by? Well, that's right, 5. So there's your common ratio. That will be called R later on. The common ratio is 5. And you can double check that from -10 to -50. Again, it's being multiplied by 5, and again, being multiplied by 5. Now, in order to get that, maybe the numbers aren't always going to be this easy. If you take this one and divide it by this one, -10 divided by -2, that will tell you what the common ratio is. So you can take 2 successive terms and divide them to get the common ratio. This one becomes a little more difficult. We have -2 to 1/2 to -1/8 to 1/32. Maybe you're recognizing what it's multiplying by. Let's figure out how we could do this. We could take any 2 terms. I'm going to take this one and this one. We're going to take -1/8 and we're going to divide it by 1/2. Now, anytime you're dividing by a fraction, you can change it to multiply by the reciprocal 2/1. So if you multiply, it becomes -2/8, which simplifies to become -1/4. And there is your common ratio, -1/4. You'll notice to get from one to the next, you multiply by -1/4. -2 times -1/4 is 1/2, and so on and so on and so on. So if you're unsure of how to get that common ratio, just divide them and then simplify. Try the next couple on your own. You might want to pause the video here just to give yourself enough time. And when you're done, come on back and we'll show you how to determine the common ratio by jumping up a bunch of terms. All right, hopefully those weren't so bad. Next example says, determine the common ratio in the following geometric sequence. So it's starting with the 500. That's your first term. We have some second term, a third term, a fourth term, a fifth term, and we do know that the 6th term is 163.84. So to get from the first term all the way to that 6th term, you're going to have to multiply by some common ratio. Let's call it R. So we're starting with 500, and we're multiplying by R once, twice, 3 times, 4 times, 5 times. So it's times R, times R, times R, times R, times R. And when you do that, it equals 163.84. Now let's simplify that. We can start with 500 times R to the 5th power equals 163.84. So we had to multiply by that same common ratio 5 times in order to get to that 6th term. So if I want to solve for R, we can just divide by 500. And we're left with R to the 5th equals whatever decimal this gives you on the calculator. Now, hopefully you remember from our last unit, if you want to get rid of something to the 5th power, you can just raise it to the 1/5 power. So whatever decimal that spits out at you, raise it to the 1/5 power or the 0.2 power. And if you do it correctly, we get r equals 0.8. There's your common ratio. So what's happening is from one term to the next term, it's just multiplying by 0.8. So if you took 500 times 0.8, it would give you 400. If you take 400 times 0.8, it gives you 320, and so on and so on and so on until finally the sixth term would be 163.84. So go ahead and try the next one on your own. Pause the video here, and when you're done, come on back. All right, so now what we're going to do is going to be very similar to how we approached arithmetic sequences, and we're going to take three terms and we're going to solve for an a value. So we're starting with 64, and then it's going to multiply by some common ratio. It'll give us a, and we're going to multiply by some common ratio again, and it'll give us a 4. So if you use the definition of geometric sequences, what's really happening is if you take the second term divided by the first one, it gives you a common ratio. And whatever that common ratio is, it should be equal to the third term divided by the second term. So we're going to take that same logic over here. If we take this one divided by this one, a divided by 64, that would give us the common ratio. And it should be equivalent to the third term divided by the second term. That also gives us the common ratio, and they should be the same. So what we're going to do next is solve by cross multiplying. A times a is just equal to a squared. 64 times 4, that equals 256. And then to solve, you can just square root both sides. And we get a equals, technically it's a positive or negative 16. So you can always double check your work. Let's see what happened here. We take 64, 16, and 4. To get from one term to the next, it's multiplying by 1/4. Times 1/4, and you get 4. It could also be a negative 16. So we start with 64, negative 16, 4, because if you multiply by negative 1/4, you get negative 16. Times a negative 1/4, it still ends up as a positive 4. If you look at the assignment, it says, assuming a is positive. So in this case, a is going to be the positive value of 16 because it specified that. But technically, there's two positive answers. So that one was pretty straightforward. Let's look at one where it maybe requires a little bit more math and a little bit more creative solving techniques. So to find the common ratio, you would just take the second one divided by the first one, and that's a plus 10 divided by 25. That would give you the common ratio. But that common ratio should be the same as this one here. So it should be equivalent to a plus 6 divided by a plus 10, because that also gives you the common ratio. Now we have a whole lot of variables, and we got some fractions. Let's start by cross multiplying. Multiply those together. If you take a plus 10 times a plus 10, it results in a squared plus 20a plus 100. You might have thought it's just a squared plus 100, but remember what you're doing is a plus 10 times a plus 10, distribute it all out, and you get that middle term of 20a. Then we put equals, and we have to multiply 25 times that entire expression here, 25 times a plus 6. So that would become 25a plus 150. So now we've got this quadratic equation, and we have to solve it. And hopefully you remember from the quadratics unit, to solve any quadratic equation, it's probably easiest to set it equal to 0. So let's subtract 25a from both sides. And then let's also subtract the 150 from both sides. And by doing that, we get a result of a squared minus 5a minus 50 is equal to 0. Much more simple looking quadratic equation. Now, we can solve this using a couple different methods. You could use the quadratic formula, we don't want to do that right now. You could complete the square. You probably forgot all about that one. Or we could factor it. That's going to be the easiest one if it works out. So we want to look for a set of numbers that multiplies to negative 50, but can add up to a negative 5. So here's the factors of 50. 1 and 50, 2 and 25, 5 and 10. This is the one that can make a negative 5, and to do that, just throw the negative on the 10. So you get a plus 5 times a minus 10 is equal to 0. Now to solve it, we factored it, but we haven't solved anything yet. We can set each of these parentheses equal to 0. So if we get a plus 5 equals 0, subtract 5 from both sides, we get a equals negative 5. Or we have a minus 10 equals 0. If we add 10 to both sides, we get a equals a positive 10. Now, since it said a is positive, then we know that's going to be the one. A is equal to 10. Now let's double check what actually just happened. We start with 25. And if a is equal to 10, then 10 plus 10 gives you 20. And if you plug in a 10 here, 10 plus 6 is a 16. So to get from one term to the next, 20 divided by 25 is 0.8. And 16 divided by 20 is also 0.8. So it's multiplying by a common ratio of 0.8 every single time. And that's now a geometric sequence. And there is one more to do on your own for this video. I'm going to do all the rest of it in a separate video. So go ahead and finish this one, make sure you're confident with it, and then watch the next video to see how this finishes up.